Okay, so in this video, we're going to show that we can do a turn, and we're going to make the point that it's actually really important to do this analysis and to include that turn because, of course, turns can lead to tips as well, that the whole forklift could tip over via centrifugal loading. All right, so anyways, let's bring this back to here. And again, first thing I want to do is really just kind of, provide my criterion. It's the same thing we've been doing before, which is the idea of one of my bearings connecting the motion platform to the vehicle is going to experience a negative load, meaning it's going to be trying to pull the vehicle down to prevent it from tipping. And so let's zoom here. I didn't do that very well. All right. And let's get my select button back. All right. All right. And so I click on the vehicle. The vehicle is the big red box. All right. And here I'm going to hide it. Okay. I'm going to remind you about the motion platform. Obviously, I've upgraded it a little bit, and I'll probably have some follow-on videos showing how I did that. And from here, I want to really just focus on the motion platform. So let's take that and let's hide everything else. Let's show only this. All right. And let's do good ISO fit and maybe rotate it a little bit. Okay. And put my glasses on. Right. And then what we've been doing up to now has really been kind of a pitch analysis because we've been moving it only in a straight line. And it's really been between what I've been calling the front axis, which is represented by one joint, and then the rear axis, which is really occurring because of two. And we'd have to go back a couple of videos, but in a couple of videos ago, we created the connections between the vehicle and the motion platform. And you might recall that the rear right is what I call a spherical joint. The rear left is a spherical joint on a slot with, the degree of freedom to slide in, if you look close, would be the y-axis. Now, it doesn't slide in that direction because we already created the spherical joint right there. So this is one that really kind of sets a point. So, so it's not going to move between the vehicle and the motion platform, right? And so then we have the front axis was our third one. So three constraints between the two essentially act as a rigid joint. But what's really important about doing it this way is that we can kind of get through what I would say the proper moment arms, the actual vertical loading, for the front axis, and then we even differentiate on the rear axis between the left and the right side. All right, and so again, I brought you to this idea that put yourself, in a car that's going around a turn, or maybe even more importantly, in a roller coaster car that's going around a turn. And certainly, I think you'll have a recollection of experiencing a significant centrifugal force, right? And that, to be very specific, the centrifugal force will be acting outward, meaning away from the center of rotation. And so with kind of the geometry of the vehicle, that would lead to a tipping that would go outward as well. And therefore, it's the job of this rear left constraint to really hold it down. And as soon as it gets into the hold down mode, which means it's going to apply a negative Z force, well, that's our indication of tipping. Right. So let's look at this from our data inspector. So in the previous videos, we've been looking at the rear axis and the front axis together. And then it's always been good to do, let's see, where is it? Vertical force on vehicle. Okay, the fact that that's zero throughout, that's a validation that we did our calculation right. But also, it's always nice to see where zero is. All right. And, certainly this trajectory, this mission is not going to tip via pitching. All right, but it's probably a little bit risk at rolling. All right, and so I put these two additional measurements in. You'll see the front, I named them wrong. These should be the rear right bearing and rear left bearing. I'll fix that later. But we'll see, as I indicated, that the left bearing is really the one that's coming close. And you'll see it right there. Perhaps I can zero in or zoom in a little bit. And it looks like it's carrying, or it's still in compression and it's pushing up a mere probably like 70 or 80 newtons, right? Let's get back there, right? And I think I said this will be a quick video. And the last piece to this is I really just want to kind of show mission variations can lead to tips. And so I'm going to raise the forks like I had before, period of 2 seconds. Let's rerun the calculation. Let's bring everything back. Right mouse click, show everything. Let's do a fit. Maybe I think I'll just hit this isometric view again and maybe zoom back just a little bit so we see the whole turn. Right. And I am going to run this one now in real time. So you'll see I was running at 8x. So bring it back to 1 times real time. Takes the 2 seconds to raise the forks. And now I'm going to just talk a little bit about, why this will be more precarious. And I think it's become very familiar to me at this point from doing these types of analysis. But we got much higher moment arm, and that's because the moment arm for tipping will be the center of mass of the overall vehicle relative to, where those bearing connections are, right? And so with this, and of course, this will depend on how heavy our load is, but again, the more thorough exploration of I'd say the design of the system and its ability to operate as it's intended to, well, that'll be a more thorough analysis. But I think I'm showing that analysis is available through what we're doing with MATLAB and Simulink. And anything that I'm missing, I'd love to talk to the forklift developers out there. We'll add stuff. We'll add hydraulics. We'll add batteries. We'll perhaps get much more realistic, I'll call distribution of mass to identify things like center of mass, verticality more accurately. But let's wrap up by just going to the new calculation. There's that left bearing, and absolutely it goes negative, and that run, that trajectory at that speed would lead to a tip. Thanks for watching.